Good afternoon, ladies and gentlemen. Welcome to the international webinar on using model technology to optimize production of an oil field, organized by Advanced Research Society for Science and Sociology in association with IRAJ Webinars. On the behalf of entire organizing committee, I'm Isaac Behra, organizing secretary. Would like to welcome you all for this webinar. Ladies and gentlemen, let me introduce our organization. The motto behind this non-profit association is to bridge the gap between students, professors, academics, and industrialists from multidiscipline. Apart from organizing various seminars, expert talks, and conferences, we have various highly rated multidisciplinary journals in the field of science, engineering, technology, and management. Since our inception, we have been arranged various international conferences at various parts of the world, like New York, London, Australia, Hong Kong, Dubai, Bangkok, Kuala Lumpur, India, etc. More than 1 lakh people across the globe are associates with us, and more than 5 lakh research papers have been presented and published during our journey. Today, I'm glad to welcome you all as a member of this fastest growing network for the advancement of science and technology in terms of research and innovation. Today, we were very much fortunate to have an eminent professor and expert who is joining this webinar as an expert speaker and guest. His name is Professor Dr. Abdollah Esmaeili. Presently, he's working as an associate, as a professor at Al-Farabi Kazakh National University, Almaty, Kazakhstan. Now I'd like to welcome our Professor Abdollah Esmaeili to deliver the webinar.
Thanks a lot.
Thanks, sir.
Thanks a lot. So we can start, yeah?
Yes, sir.
Okay. Good morning, ladies and gentlemen. We are happy to start our presentation here. The title is Modeling Technology to Optimize Production of an Oil and Gas Field. The audio, everything is okay?
Yes, sir.
Audio, video, everything is okay?
Yeah, everything is okay, sir.
Okay. So as the title here, you can see we use modeling technology to optimize production for an oil field. And we are going to discuss about this technology today. First of all, as you know, the production of hydrocarbon fluid. Just as a question, how many time we will have for presentation and how many time we will have for question and answer?
So it would be for one hour, sir, 12 p.m. to 1 p.m.
Totally 1 hour, yeah? So
yes, sir.
Around 1.5 hour for presentation, 1.5 hour for question and answer, yeah?
Yes, sir.
Okay, okay. So coming back to our presentation, and here, as you can see here, the production system of a unit will be via production system. The production system has different parts, as you know. And we are going to optimize these different parts if we want to optimize the production. You can see here in this figure that reservoir management, first of all, we must be able to manage a reservoir. In reservoir management, we will use a system for what? A system for modeling. So we need a system model. And the various part of the system optimization, sensors, input data, and all the accessory points you can see here in these figures. This is a good figure for your general perspective. So the production system can be categorized to when, according to our division, according to our division in petroleum industry. So inflow that reduces to the fluid from cross media to the media. So we can divide this to 3 parts. The fluid will start from the reservoir to the wellbore, then from the wellbore to the wellhead, then from the wellhead to the production unit. or to the refinery, or to the any other units. So we will have three parts. First of all, in our system, first of all, from the reservoir to the wellbore, then from the wellbore to the wellhead, then from the wellhead to the production. So if we want to optimize this system, we must be able to optimize total of this system from reservoir to the wellbore, from wellbore to the wellhead, from wellhead to the production unit. So by using available methods, but how we can? Here at the first line you can see, by using available method, any part of production system can be modeled. Yes, but how? We are here. We are here to discuss about it, but how? Inflow information of production systems such as reservoir pressure, temperature, fluid type, and post-media characteristic, and vertical well formation like well geometry pressure control devices can be used to model the production system. And after modeling, but what will happen after modeling? After modeling, we must be able to interpret it. So not only the modeling is very important, but interpretation is more important than modeling. So after modeling a production system, any problem can be specified, then proper method will be able to remove them to solve our problems by modeling. Okay. So what will happen in this study? In this study and in this research, we will select two wells of an oil reservoir. As you know, in an oil reservoir, we have a lot of oil and gas wells. Maybe 100 wells, maybe 200 wells, maybe 300 wells, sometimes more than 300 wells. In simulations, of course, it's not possible for us to simulate or to model total of these wells. So we will select two of these wells and we will compare them together and with the actual case. Sorry. So nodal analysis techniques, but what techniques we will use? We will use nodal analysis techniques to analyze tubings and choke size for this wells. But what will be the objective of horizontal optimization methods? Our objective is in optimization, first of all, is to find the optimum rate. Then we must be able to optimize our other facilities. So according to this second sentences, you can see here, well inflow performance relationship, IPR, and tubing performance relationship, TPR, and basic requirement for analysis. We will use total of these data in our modelings. Okay, analyzing well performance. How it can be done? Analyzing well performance is an important step to optimize production by improving production technologies. The analysis can be, but this analysis, how can it done? This analysis can be performed by well test and examination of the well data. Data gathering was the main problem of this study, yes. Not for this study, but also for our total studies. Data gathering at the first is very important because, as you know, our studies will be based in our data. If our data has some errors, so the modeling will have some errors. So we must be careful with the data at the first step. But which this analysis can, of course, can be done by the software. But which software, as you know, we have several software for modeling. We have several software for modeling facilities at the surface, at the ground, and we have some several software in industry, oil and gas industry for underground, and have some software for surface, to modeling our devices of our production unit at the surface. So generally, our modeling software will be divided into two groups. One group to model our activities underground, and one model will be used to model our activities at the surface, at the ground. Okay, so coming back to our presentation, at the second sentence, you can see for this purpose, we select two wells, A and B, from a reservoir with the versus data as the following: PI test, fluid test, geometry data, and other data which we have. Then this data was analyzed by software. Okay. So PI test, as you know, pressure index. Pressure in PI test is the abbreviation for pressure index for the well. Will be used in a short time, therefore that cannot be detected by the correct maintenance of the skin permeability. They show only approximate amount of skin and permeability, as you know. After that, by using software, tubing size, choking size for this well were examined. Also the analysis effect and inflow performance in the production, skin factor and reservoir pressure will be analysis. And we will have some tables, same as table 2 and table 1 and table 2, which show the well reservoir fluid properties, and data on production collection will be collected for well A and well B. Table 1, this is the well A, well A and well B. This is the data: bubble point pressure, bubble point temperature, and oil gravity, and finally the oil formation thickness, for example. Table 2, production condition of well A and B, for example, production rate, reservoir pressure, GOR, water cut, other properties. In PIT data, you can see here that what will be happening in PIT analysis. This PIT analysis, this is for well A. This analysis can be done, as you know, by PANSYS software. It can be done by Eclipse 200. So we have several software for this purpose, for this analysis. This is in log plot. This is radial in radial flow plot, and here this is in log plot. Again, we will have, this is for well B, and this is log plot for well B. The result of PIT test and analysis by software is including the skin factor and reservoir permeability are summarized here. So here for well A, for well B, the skin factor and permeability. How we can get this data? By analysis and by well test and PIT. As you know, coming to this here, for permeability, as you know, in petroleum industry, we can get permeability and skin factor from the log, and at the same time, we can get this data, of course, from the laboratory in well test and so we have two separate methods: well log, by well logging, or by well testing. In question and answer section, if you have any question, we can discuss further. So let me to go faster because we must manage the time. Okay, analyzing the product condition of well A and B fluid. Now we will have flow correlation matching. Here, correlation matching for well A, and here flow correlation matching for well B. How? By software. And tubing size analysis. As you know, tubing in the oil and gas well is very important to optimize the production. Not only tubing, but also casing is very important in design. But in discussion further, we analyze the tubing size here, as you can see. So this is the IPR and TPR curve for well A. according to the software. This is IPR and TPR curve for well B. And as I told you at the beginning, that we will use nodal analysis. You can see that in Figure 9 and Figure 10 show the APR and TPR curve for different tubing sizing of well A and well B, which are developed using nodal analysis. So we use nodal analysis to analyze our results. In Figure 9, you can see here tubing size performance analysis for well A, nodal analysis by using nodal analysis. In Figure 10, you can see here, this is for well B, again by nodal analysis. As you can see here, this is APR for Radial Correlation, TPR tubing pressure resistance relationship. This is for internal diameter, this tubing internal diameter test, and this is for internal diameter test. So for several various internal diameters, you can see the relationship between the liquid fluoride, between the tube, between the fluoride and the well flowing pressure for the various sizes of tubing. So we are going to determine which one is better. We are going to optimize which one is better, which one is the best case. But how? You can see here is these figures by using the software. Okay, reservoir pressure effects. What will happen in reservoir pressure effects? Figure 15 and 16 will show this. So here for analysis, the reservoir pressure depletion, as you know, reservoir pressure depletion is very important. So pressure drop is very important in a reservoir. So how we can increase the pressure, how we can stabilize the pressure. At the first step, we are thinking to how we can stabilize the pressure. At the second step, we must think to how we can not only stabilize the pressure, but also how we can increase the pressure. So here, the effect of pressure depletion of well A. So the pressure depletion in well A, liquid fluorides, you can see here, well flowing pressure, you can see here, and for various static pressure. This is for this is static pressure, or this is for various static pressure, what will be happening? And this is another one, Figure 16, effect of reservoir pressure of well B, and skin effect. What about the skin effect? For analyzing the skin effect on APR curves, pseudo-steady state equation for inflow performance relationship IPR were used. They are summarized in Figure 15 and 18, show the effects of a skin factor or IPR curves for well A and well B. So here we write here that pseudo-steady state equation will be used. But why pseudo-steady state? Maybe you ask me in question and answer section. Why? As you know, in cross-media and in chemical engineering, petroleum engineering, we used two types of equations, or in real state or completely steady state, or ideal state or steady state, in unsteady state and in pseudo-steady state. So the question is here that we will discuss about that in question and answer section, that why we used pseudo-steady state equation. So effect of a skin factor or IPR curve for well A, you can see here for well A, this is for well A, and skin factor, this is for well B in IPR curve. This is for well B. That what will be happening for the skin factor? Skin factor 0, skin factor 2, skin factor 5, 1, 3, and 6. Okay. Conclusion. So first of all, well analysis is an excellent method for indicating how to optimize the well overall performance. But How we can do it? By several software. As I told you, we have two types of software. One type for modeling our activities for underground. One type of software will be used to model our activity at the surface. The second point is to use the correct data, because as you know, the input data is very important to get a good result, to optimize the production. Three parameters, generally three parameters must be optimized in operation, as you know: Q or flow rate, pressure, and we have three main parameters which must be controlled, must be monitored at any time at the operation, in oil and gas industry: pressure, temperature, and flow rate. Of course, we have a lot of other parameters, but three of them must be optimized and must be controlled and must be monitored at any time. Okay, thanks a lot for your attendance, and coming back to our question and answer section. If you have any question, especially challenging question, we are going to discuss in this session. Okay, thanks. Any question?
Thank you, Professor, for sharing your valuable time and for joining this webinar. On the behalf of organizing committee ARSSS, IRAJ Webinars, I would like to present a certificate of appreciation to you, sir. Kindly accept it.
Thank you. Any question from the participant, engineer, our friends?
I think there will be no questions, sir.
Okay, so everything will be, I think everything will be clear for everybody, yeah?
Yes, sir.
Okay, thanks, and see you in our next sessions.
All right. I would like to thank all our sponsors and coordinators. I would also like to thank our president. We're happy to hear your comments and compliments or suggestions at our Facebook and Twitter page. This video will be available shortly in your YouTube channel. Kindly subscribe our official YouTube channel, IRAJ Conferences and Seminars, for all past and upcoming webinars and expert lectures. Link is in the description box. Thank you all. See you on the webinar soon.